Hi everyone, welcome back to ANR Academy. Today I am here with you to discuss about cevians and then we go for Ceva's theorem. See, if there is a triangle ABC, then there exists line segments whose initial point one of vertices and the other end point on opposite side. Then those line segments are called cevians of the triangle. Cevian is a line segment joining vertex to any point on opposite side of that vertex. This is one more cevian. Why? Because it is also joining a vertex and a point on opposite side of the vertex. So there exists infinitely many cevians passing through a vertex. These are all cevians of the triangle. Also you can draw from the vertex B and also from C. From B if you draw, these are all called cevians. Just the line segment which is joining a vertex and other point which is lying on the opposite side. From vertex C also there exist many cevians. First one, second one, third. So in this way we get cevians. There are infinitely many passing through three vertices. Next, let us move to Ceva's theorem. The statement of Ceva's theorem. Suppose in triangle ABC, AX, BY, CZ, if they are cevians, then BX by XC multiplied by this is triangle ABC and here the cevians are AX, BY, CZ. AX, BY, CZ cevians and they are concurrent. That is passing through one common point. Then the result Bx by Xc multiplied by Cy by Ya multiplied by Az divided by Zb. It is equal to 1. This is the statement of Ceva's theorem. Here P is the point which is interior to the triangle ABC. If AX, BY, CZ passing through the point P, then BX by XC multiplied by CY by YA multiplied by AZ by ZB, the result become unity. This you have to prove now. Let us see the proof of this. I am going to select a triangle. Vertices I am going to mention ABC. A, B, C. Concurrent cevians you have to select. First one. Suppose this is AX. Next, BY. This is CZ. And assume that their point of intersection P. Now I am going to write area of triangle BPX. Area of this triangle BPX. BPX, here it is of height, suppose small h. I can write half into base value bx and height small h. Next I am going to write area of XPC or CPX. Area of triangle CPX I am writing, that is half into, here base value Cx. Both the triangles are of same height, so that here you have to write height h. This is result 1, this is result 2. Area of triangle BPX, this one, and area of CPX, this area. These are the two results. Now I am going to write area of triangle BAX. Delta BAX half into, BAX is of same base BX. Suppose that height of the triangle, here I am going to mention the height. Suppose that this is some capital H. Assume this is third result. Next I am going to write delta CAX. Half into, for the triangle CAX, base is XC or CX and of height capital H. This is result 4. Now divide 1 with 2. Apply 1 by 2 as well as 3 by 4. What happens? Observe. 1 by 2 implies delta BPX divided by delta CPX. This is equal to ratio of these two. H and half gets cancelled. We get BX divided by XC. Next, 3 by 4. Half and capital H gets cancelled. We get delta BAX whole divided by delta CAX equal to again BX by XC. Both are having the same ratio BX by XC. We know that by ratio proportion, suppose that if A by B equal to C by D, then also you can write it is equal to A minus C by B minus D. Here these two are equal. BX by XC equal to delta BPX divided by delta CPX also equal to delta BAX divided by delta CAX. These two ratios like A by B equal to C by D. So by ratio proportion I can write it is also equal to A minus C by B minus D. Here I am going to write delta BPX minus delta BAX whole divided by delta CPX minus delta CAX. Therefore, finally you will get BX by XC value. See here from the figure, delta BAX is greater compared to delta BPX. So I am going to write here plus sign and here minus sign. If I write here plus sign, here it should be plus, here it should be minus. BAX is greater compared to BPX. So from greater area, if you remove least area, we get area of BPC. From this entire triangle area ABX, we are going to remove BPX so that you will get the area of APB. So here it is delta APB divided by, next from delta CAX is this greater triangle, from this we are going to remove area of CPX. So you will get APC area. So delta APC we get. This is star mark. We got first ratio BX by XC. See, BX by XC become area of delta APB divided by area of delta APC. I am going to shade the region APB. This is the shaded portion of APB. Next, APC. This is the shaded region of APC. So, BX by XC, area of BPA divided by area of CPA. In the same way, I can write CY by YA value also. CY by YA I am going to write. When you have CY, then you have to write BPC. Delta BPC divided by, next you have in the denominator part by A, for which we get APB. Delta APB. Next, AZ by ZB. Similarly, you can write for AZ we get APC in the numerator, delta APC divided by, next BPC delta. This is double star. Third ratio, suppose this is triple star. Now, final result I am going to write. BX by XC equal to final result BX by XC multiplied by, next CY by YA multiplied by AZ by ZB. See, BX by XC from first star, area of triangle APB divided by delta APC, first result. Next multiplied by CY by YA, that is delta BPC divided by delta APB. Next AZ by ZB, that is delta APC divided by delta BPC. Delta BPC gets cancelled. Delta APC gets cancelled. Delta APB gets cancelled. So finally, it gives the result 1. Therefore, I can write here Bx by Xc into Cy by Ya into Az by Zb. That become 1. This is about Ceva's theorem. Cevians nothing but they are the line segment joining vertex to any point on the opposite side of the triangle, on the opposite side of the given vertex. Next, Ceva's theorem says that if 3 cevas are concurrent, that is passing through a common point P, then their sides ratio Bx by Xc multiplied by Cy by Ya multiplied by Az by Zb, that become clearly 1. I hope you have understood everything. Please, those who are watching my videos, please subscribe the channel, and also don't remember to like, share and comment on this. Thank you so much.